This is question number 11 of exercise 5.1 from the chapter Continuity and Differentiability. The question is, find all the points of discontinuity of f, where f is defined by fx is equal to x cube minus 3 if x is less than equal to 2 and x square plus 1 if x is greater than 2. Now to solve this question, first of all we take the first case, and the case is when x is less than 2. So in this interval we assume that c is any number less than 2. Okay, so limit of x tends to c of this function fx would be equal to limit of x tends to c for x cube minus 3, and this would be equal to, on applying the limits, c cube minus 3, and f of c would be equal to c cube minus 3. Okay, and you can easily see that fx, this function fx, takes the value in the interval x is less than 2, the value x cube minus 3. So this gives me that limit of x tends to c for fx is equal to f of c is equal to c cube minus 3, and this is valid for all the values of c less than 2. Therefore fx is continuous for all the values of x less than 2. Now we are going to take the second case when x is equal to 2. We have to take this case because the function changes the value at this point, and for this we are going to take first of all the left hand limit of the function when x tends to 2, that is limit of x tends to 2 negative of fx. This would be equal to limit of h tends to 0 of f of 2 minus h. F of 2 minus h value will be calculated by taking fx as equal to x cube minus 3, because 2 minus h is less than or equal to 2. So this would be equal to limit of h tends to 0 of 2 minus h whole cube minus 3, and on applying the limit this would be equal to 2 cube minus 3. Okay, and this would be equal to 5. So right hand limit of the function when x tends to 2 would be equal to limit of x tends to 2 positive of fx, and this would be equal to limit of h tends to 0 of f of 2 plus h, and this would be equal to limit of h tends to 0 of 2 plus h whole square plus 1. On placing h is equal to 0, this would be equal to 2 plus 0 whole square plus 1. That is, on applying limit we are going to get this value. So this will again be equal to 5. Now f of 2 is equal to 2 cube minus 3 or equal to 5 again. So left hand limit is equal to right hand limit is equal to the value of the function when x is equal to 2, and this is equal to 5. Therefore f is continuous when x is equal to 2. Now we are going to take the third case when x is greater than 2. Let c be any real number and c is greater than 2. So limit of x tends to c for fx would be equal to limit of x tends to c of x square plus 1, because fx takes the value equal to x square plus 1 when x is greater than 2, and this would be equal to c square plus 1, and f of c will also be equal to c square plus 1. Okay, so limit of x tends to c for the function fx is equal to f of c is equal to c square plus 1. So this means that f is continuous for all x greater than 2. F is continuous for all real numbers, as we have considered all the three cases. So f has no point of discontinuity, which is the required answer. Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.